Hello friends. On June 25, 2026, millions of people woke up to a surprise. Apple had quietly raised prices on its MacBooks and iPads overnight. The MacBook Air jumped from $1,099 to $1,299. The MacBook Pro went from $1,699 to $1,999. Apple stock fell more than 6% that day. CEO Tim Cook told the Wall Street Journal it was unlike anything he had seen in over 40 years in the industry. He called it a 100-year flood. But here is the question worth asking. Why would an AI boom in data centers make your laptop cost $200 more? The answer lives inside a tiny but critically important piece of computer hardware called DRAM. To understand the crisis, we first need to understand what RAM actually does. Alright, to understand the crisis, you need to know what RAM actually does. RAM stands for Dynamic Random Access Memory, or DRAM for short. Think of it like the desk in your office. Your hard drive, or SSD, is the filing cabinet across the room. It holds everything permanently, but getting data from it takes time. DRAM is the desktop surface where you keep only what you are working on right now. It is fast, it is temporary, and when you power off, everything on it disappears. Every computing device you own relies on it. Your phone uses a low-power form called LPDDR. Your laptop uses it. A cloud server holds hundreds of gigabytes of it. Without enough DRAM, your CPU and GPU sit idle, starved of data. It is the bridge between the thinking and the storing, and right now, that bridge is in a full-blown supply crisis. Now look at this. AI companies are not buying ordinary DRAM. They need a completely different, far more complex form called high bandwidth memory, or HBM. Here is how it works. Engineers take individual DRAM dies, thin slices of silicon, and stack up to 16 of them in a vertical cube, like a tiny tower. Microscopic vertical wires, called through-silicon vias, connect each layer. That finished stack sits right next to the GPU on a shared silicon base called an interposer. This shortens the distance data must travel, and bandwidth explodes. Nvidia's Rubin GPU, shipping in the second half of 2026, packs 8 of these HBM4 stacks per chip, delivering 288 gigabytes of memory at 22 terabytes per second. Each stack uses up to 16 DRAM dies. That means up to 128 DRAM dies in a single GPU chip, all pulled from the very same fabs that make the memory inside your laptop. And that is exactly where the trouble starts. So where does the crunch actually come from? Here is the core problem. Samsung, SK Hynix, and Micron together control more than 90% of global DRAM production. Every silicon wafer those three companies make is a choice. They can slice it into consumer chips, the kind that goes into your MacBook or your phone. Or they can run it through a far more complex stacking process to build HBM for AI servers. And right now, HBM wins that choice every time. Industry analysts estimate HBM earns 3 to 5 times more revenue per wafer than standard consumer memory. So as AI demand exploded in 2026, these companies systematically shifted wafer after wafer toward HBM. That is a zero-sum game. Every wafer moved to HBM is one fewer wafer making the LPDDR chips inside your laptop. That is the mechanism connecting Nvidia's AI hardware to your MacBook's price tag. And next we will see exactly how dramatic that shift has been in the numbers. Now let's put real numbers on this. According to TrendForce, conventional DRAM contract prices surged up to 98% in just the first quarter of 2026 alone. That is nearly a doubling in 3 months, the largest quarterly jump on record. TrendForce then forecast another 58 to 63% rise in the second quarter. At the same time, every major memory maker confirmed their 2026 HBM supply is completely sold out, locked under multi-year contracts with hyperscalers like Microsoft, Google, and Meta. No relief there. New fabs from Micron and SK Hynix will not reach meaningful volume until 2027 at the earliest, and some not until 2028 or beyond. The market reaction was immediate. On June 25, 2026, Apple raised MacBook and iPad prices to offset the cost, and its stock fell more than 6% that same day. The semiconductor engineers who designed the HBM stacking process had no idea their architectural decision would one day move a $2 trillion company's share price. So here is the big picture. A decision made deep inside a chip lab, how to stack DRAM dies in a cube to maximize AI bandwidth, flows straight through to the price you pay at checkout. Engineers chose HBM because it solves a real architectural problem. Memory makers chose to prioritize it because the economics are overwhelming. And companies like Apple, with no DRAM fab of their own, absorbed the impact and passed it to you. That chain from architecture to economics is the key mental model to take away from this video. Computer architecture is not abstract. The way memory is physically designed and manufactured determines who gets chips, at what price, and when. In this case, a structural shift in AI hardware design created a memory shortage that raised the price of a MacBook by up to $300 in June 2026. Keep that connection in mind every time you study a new architecture. Thanks for watching, and we will see you in the next one.